Alright, so hello everyone. Uh, we are Group 10 and today we are going to present about introduction to database and normalization. Our group is Muhammad Amir Hakim bin Muhammad Hussein, Abdul Ahmad bin Razaki, Harith Rashantaj Analaki Rajandaran, and me, Muhammad Azhar Safan bin Ahmad Azizi. So our main purpose to this presentation is we are going to introducing about database and concept and normalization.
Uh, Hi everyone, my name is Muhammad Hakim, and then I'm going to talk about what is database. Okay, database is a collection of organized data as data stored and accessed electronically. It is designed to store and manage large amount of data and to provide fast and reliable access to the data. And database management system, it's called DBMS, is a software application that used to create, maintain, and manage database. It's provide the necessary tools and interface to allow user and application to interact with the database. And is responsible for enforcing the rules and constraint that ensure the integrity and consistency of the data within the database. In other words, a database is a collection of data, while a DBMS is a software system that is used to manage data. While a DBM, the DBMS provide the necessary mechanism to create, read, update, and delete data in the database, as well as to enforce rules and constraints to ensure the integrity and consistency of the data. Thank you.
Hello, I'm Hari Prashant Rajendran. So next we're gonna see what is the role of DPMS. So a database management system is a software program that interacts with end users, other applications, and the database itself to capture and analyze the data. The database management system is the software that interacts with end users and software, and basically the overall system is a database. So this database management system has a lot of function. The primary function of a DPMS is mainly to store, retrieve, and manage data in a database. This includes tasks such as creating, modifying, and querying the data. Additionally, a database management system provides an interface for users to interact with the data, such as through the use of SQL. And also a DPMS also provides tools for managing and maintaining the database, such as backup and recovery, performance monitoring, and security. So another key role of DPMS is managing concurrent process to the same data. Concurrent access means multiple users can access the same data at the same time and make changes to it. Not only that, DPMS provide mechanism to handle this concurrency of access to make sure the data remains consistent even in the event of multiple user accessing at the same time. So long story short, DPMS is a critical component of any system that needs to store, retrieve, and manage large amounts of data. It provides a way for users and other systems to interact with the data in a controlled, organized way. And also, it's essential for maintaining the integrity, security, and performance of the data.
Okay, so hello everyone. Right now, me, Abdalama, and Amiro are going to talk about the advantages and disadvantages of database management system. So, the advantages of database management system. So, first of all, database management system is a software program that interacts with end users, other applications, and the database itself to capture and analyze the data. It provides the necessary tools and interface to allow users and application to interact with the database. As I continue, there are a lot of advantages of using DBMS. The first one would be the data integrity. The DBMS ensure the integrity of data by enforcing constraints and rules on the data stored in database. This ensures that the data is consistent and accurate. The second point, which is data security, the DBMS provides a variety of security features such as user authentication, access control, and encryption that can be used to protect the data stored in the database. The third point, concurrent access. The DBMS allows multiple users to access the same data simultaneously, which can increase the productivity and efficiency of an organization. The fourth point, backup and recovery. DBMS provide tools for creating and storing backups of the database, which can be used to recover from data loss or corruption. The last part, data sharing. DBMS allows data to be shared easily among different applications and users, which can improve collaboration and decision making. Thank you.
Now I'm going to talk about disadvantages about DBMS. First is complexity. DBMS can be complex to set up, manage, and use, which can make it difficult for some users to understand and work with. And then DBMS also costs, it can be very expensive to purchase, set up, and maintain, which can be a significant cost for some organization. And third, overhead. DBMS can introduce additional overhead and latency when accessing data, which can affect the performance of applications that use the database. And fourth, vendor lock-in. Depending on the DBMS you are using, you may be dependent on a specific vendor and have limited option for migration and updates that can be problem in the future. And then scalability, as the amount of data stored in a database increase, it can become difficult to scale the DBMS to handle the increased load, which can affect the performance of the system. And the last, it depends on the IT. Since DBMS is a technical solution, it will require an IT department to manage and maintain the DBMS. And the database and it manage, this can become a bottleneck to the organization, as if IT department are too busy, it can cause delay or issue to the rest of the organization. Thank you.
So we're gonna talk about normalization. So what is normalization and why it is important in database design? Normalization is the process of organizing a database in a way that reduces redundancy and dependency and improve the integrity and consistency of the data. It is an important step in database design as it helps to ensure that the database is efficient, flexible, and resilient. There are several benefits to normalizing the database. Reduce redundancy. Normalization helps to eliminate data redundancy, which is the duplication of data within a database. This can help to reduce the amount of storage space required and make the database more efficient. Improve database integrity. Normalization helps to ensure that the data is stored in a consistent and logical way, which can help to reduce the risk of data inconsistencies and errors. Enhance data security. Normalization can help to protect sensitive data by limiting the number of places where it's stored and by ensuring that it's stored in a secure and controlled manner. Increase flexibility. Normalization can make it easier to modify and extend the database as the need of the organization change, as it helps to ensure that the data is organized in a logical and flexible way. Overall, normalization is an important step in database design as it helps to ensure that the database is efficient, flexible, and resilient, and that the data is stored is consistent and accurate. So regarding to our example, this is our report table. Okay, I'm gonna talk to the next slide. Okay, first one is the dependency diagram one normal form. So what happened is entries in a column are same type, rows uniquely identified. This diagram shows us our dependency diagram in one normal form. Second normal form conversion result. What happened at second conversion result? All attributes no key columns dependent on the key. Alright, so lastly, third normal form conversion result. So basically, all field can be determined only by the key in the table and no other column.
Okay, so we have example 2 over here. As you can see, we have this table. So in this table, there's 5 columns, and we have order ID, customer ID, product ID, quantity, and price. So a table is in first normal form if it meets the following criteria. First, there are no repeating groups of data in the table. And the sample record above is already in first normal form because there are no repeating groups of data. So this is our dependency diagram in first normal form. As we can see, we have order ID and customer ID, product ID, quantity, and price. So second normal form. A table is in second normal form if it meets the following criteria. First, it is in first normal form. There are no partial dependency of any non-key attribute on the primary key. The sample record above is not in second normal form because the non-key attribute price is dependent on the primary key order ID as well as the non-key attribute product ID. To convert it to normal form, we can create a new table product with product ID as the primary key and the price as a non-key attribute. The original table will now only have the primary key order ID and foreign key product ID as non-key attributes. So this is the diagram, as you guys can see. So this is the dependency diagram in second normal form. And dependency diagram in, there's a typo, in third normal form. So third normal form, a table is in third normal form if it meets the following criteria. So a table is in third normal form if it meets the following criteria. It is in second normal form. There is no transitive dependency of any non-key attribute on the primary key. The sample record above is now in third normal form because quantity is dependent on the primary key order ID and customer ID is dependent on the primary key order ID, where the foreign key product ID and there is no transitive dependency. And yeah, thank you.